Welcome to qnawire.
So now we'll work on problem 54 from chapter 17. In this problem, we have three parts. In the first part, we're told that the molar solubility of lead bromide at 25 degrees Celsius is 1.0 times 10 to the minus 2 moles per liter. Calculate KSP. So we're dealing with lead bromide, PbBr2, and we're told that the solubility is 1 times 10 to the minus 2 molar. So we know that KSP for this compound will be equal to the concentration of lead times the concentration of bromine squared. And so the concentration of lead, if we have a saturated solution, or based on the molar solubility, is 1 times 10 to the minus 2. And the concentration of bromine would be 2 times that because of the stoichiometry of the compound. And we square that value. And that gives us a value of 4.0 times 10 to the minus 6 as our KSP value for lead bromide. Now in part B, we're asked if 0.0490 grams of silver iodate dissolves per liter of solution, calculate the solubility product constant. So they're giving us the solubility in grams per liter. So what we need to go ahead and do is convert that to moles per liter. So we have 0.0490 grams times 1 mole divided by the molar mass, which is 282.77. And that's equal to 1.73 times 10 to the minus 4 moles of silver iodate. And this, we're told, is per liter, so we can go ahead and say that this is the molarity. So we can now simply plug this into our expression for KSP. So we know that KSP should equal the concentration of silver ions to the times the concentration of iodate. And we know that both of them are 1.73 times 10 to the minus 4. So all we have to do is square, and we get a value of 3.00 times 10 to the minus 8 for our KSP. So then in part C, we're told that using the appropriate KSP value from Appendix D for calcium hydroxide, we want to calculate the pH of a saturated solution of calcium hydroxide. So we find the KSP for calcium hydroxide from the appendix, and we see that it's equal to 6.5 times 10 to the minus 6. Which is equal to calcium 2 plus times hydroxide OH minus squared. And if we substitute x and 2x here, because of the stoichiometry, we get a value of 4x cubed. So now we can solve for x. We get x is equal to 1.18 times 10 to the minus 2 if we divide both sides by 4 and take the cube root. And then that is directly related to the concentration of hydroxide by multiplying by 2 because of the stoichiometry in the compound. So 2.35 times 10 to the minus 2 molar. And so if we take the negative log of this value, we get a pOH value of 1.63, which converts to a pH value of 12.37.